Hello and welcome to another episode in the GDScript Fundamental Tutorial Series. In this episode, we will be taking a look at coroutines. So what exactly is a coroutine? Well, the dictionary definition of a coroutine is a computer program component that generalizes subroutines for non-preemptive multitasking by allowing execution to be suspended and resumed. Now, that part is the most important part about coroutines, the non-preemptive multitasking by allowing execution to be suspended and resumed. That in itself basically describes what coroutines do. They suspend and resume parts of your program. Now, the definition of a subroutine is a set of instructions designed to perform a frequently used operation within a program. To understand coroutines, you must first understand what sequential processing is. Sequential processing is running code line by line from start to finish in the order your code is in. Majority of the time, your code will always run sequentially, unless otherwise specified. This would include things such as threads, which is considered concurrent processing. Let's go ahead and take a look at what a normal sequential process in your code looks like. Keep in mind that the following is pseudocode. So on our left, we have our function ready, and on our right, we have a function called add health. As you can see here, we start on the first line, and we notice how we're calling our function. What happens next is we go inside our function, and we start the first line. We create a variable, and we assign it a value that's passed down from the parameter. We then go to the next line in the code. We run that. Then we move on to the next line of code. We run that. And when we finish running all the code in our function class, we go back to our function ready and we go ahead and print the value of our health. Now that's basically sequential processing in a nutshell. So now that we understand what sequential processing is, coroutines is just a form of sequential processing, but it adds the ability to pause and resume. You can think of that as basically passing a baton to other parts of your code. So consider this is your code, the main loop. Imagine your code is running and running and running until it starts to call a function. So we go ahead and we start our function. Well, next in our function, we do have the ability to pause it. We don't have to finish all the code like our sequential processing example showed. Instead, what we can do is we can pause it, go back to our main loop, and we can keep running and running our code in our main loop until we decide for ourselves when to continue running the code in the function. And so we go back to the function, it resumes. We can do the pause as many times as we want. However, eventually our function needs to end, and then we go back to our main loop in our code. Basically, this is what a coroutine looks like if we were to visualize it. So moving on, let's go and take a look at what a coroutine process would look like. So in our first line, we have a variable. It's been declared already in the global scope. So we run this line of code. However, we are using an assignment operator. And as you know, with assignment operators, we run everything to the right of it. And to the right of our assignment operator is our function call. So we go ahead and we run the first line of code in our function. We move to the next side. And as you notice, we run into a yield statement. A yield statement just basically means we want to pause our function. So now that we paused our function, we move on. As you notice, we come back to our line of code with the function call in it. We finish everything to the right of the assignment operator, and now we gotta do everything to the left of the assignment operator, which is assign a value. In this case, because we called the yield statement, what we're going to do is we're actually going to pass a value to our variable z. In this case, basically the value being passed to variable z is just a memory object that contains the state of your function. So moving on, we move to our next line of code, and we just keep going on until we decide we want to resume our function. In this case, we call our variable z, and we use the resume method. We come back to the yield statement. Because it already ran, we just continue moving on like you would normally with sequential processing, and you just continue on with your code. How exactly do you go about using coroutines? Well, it's fairly straightforward. What you want to do is use the yield method inside the function you want to pause and pass the baton to a variable variable inside your calling function. When you want to continue with the paused function, use the resume method of the variable that holds your baton. So as you can see here, our variable z is inside our calling method, which is function ready. Now when we run our function and we hit the yield, we return back our baton, which is just a memory object that stores our function state. So now variable z holds that memory object, and when we decide we want to continue with that function, we just call that variable, followed by the dot notation, followed by the resume method. Now, one cool thing about coroutines in GDScript is that the resume method can pass data back to the yield method, or the yield statement. So as you can see here, we have our variable that holds our memory object of the function state. We call the yield, we're assigning a value yield to a variable. So as with all assignment operators, we run the code to the right of the assignment operator. So that's the yield. So basically we pause on this line of code. We come back, memory object is inside variable z. And then with the resume method on variable z, we can pass back a value to the yield function. And so we're passing the value 100. We come back to our function and we resume. Because we ran everything to the right of the assignment operator, we pass back the value 100 to our variable x. And as you can see here, we're printing that out to console and it will print out 100. This is a good way when you want to pass values to a function with the intentional purpose of pausing it, basically waiting to get a value before finishing your function. Another thing to note in GDScript is that you can use multiple yield statements inside your function. Just make sure you keep track of your yields. So as you can see here, we again have our variable z, which will hold the memory object to our function state. As we're running, notice how we run into our first yield. We come back, we hit the resume, we pass that value 100 to the variable x. We move to the next line of code. We move to our second yield statement. We come back and notice how our resume is going to pass back another memory object of our function state to a variable a. And then our a variable is going to go ahead and use the resume function. And then we're just going to continue on with our code. Now the yield statement can pass back two arguments, an object and a signal, which has to have a string value attached to it. So this is a pseudocode. As you can see here, you have your object and then a string value with the name of your signal. And down here is an example of how you would use it. Most of the time you would just get the node of the persistent node that's in your scene, followed by a name of the signal you declared in the node script. This handy feature of our yield function in GDScript basically creates a connection to an object. So when you receive a signal, you will resume your paused function. Basically, by combining the power of signals and coroutines, you can do quite a lot of stuff in terms of game programming. There is this question, when do you go about using coroutines? And truthfully, it depends on the goal you're trying to achieve with your code. Keep in mind that there is more than one way to write your code to achieve some type of goal, and coroutines is just one way of doing that. What coroutines excels at is when you need to pause a function until some state has been achieved, and usually this is done in conjunction with signals. Let's take a look at how you would use coroutines with signals. So first you have a player that's in the idle state. Basically, most likely in its process virtual method, you're checking to see if your player is damaged. And if your player does take damage, you want to enter a damage state. And in this damage state, you want to play an animation. But at the same time, you don't want your class to calculate damage taken, because while your player is in the animation, or rather when your player is in the damage animation, you don't want to calculate damage being done to the player. Basically, you want your player to be immune to damage for the length of time that your damage animation takes. So in this case, you would use a coroutine. You would pause your damage function and you will wait for the damage animation to finish. And once the damage animation has finished, you want to send a signal back to your player to let it know that you have finished the damage animation, and then you go ahead and you resume calculating damage for your player. And basically this repeats itself. This is one example of how you can use coroutines with signals to achieve a goal. signal in your game program. Now let's go ahead and take a look at some code. So over here, I have two classes, or rather two scripts attached to two persistent nodes in the scene tree. The first is our player script, and our second is our scene script. Now, as you can see here in our player script, all we're doing is we're creating a signal. We have a timer. We add that timer to the scene. Basically, we're saying that every 2 seconds, we want to call the test function. And in our test function, we want to emit our signal health, and we want to send out a signal with the value 200. That's basically all the player script does. It's basically just a timer where every 2 seconds, we call our test function. Basically, every 2 seconds, our player class will emit a signal. Now, the meat of everything is in the scene tree. So first, we have our ready function, and as you can see, we have our variable that's going to hold our object memory that holds the function state. We're going ahead, we're calling the function coroutine, and notice in the first line, we are declaring a variable stop. We're using the yield function. So since we run into the yield function, we go back to our ready virtual method, and now we pass that memory object for the function to our variable z. We go ahead and we print that out. If you run this code, you're going to see basically where it exists in memory object, or rather you're just going to see the ID that it has been assigned. And then notice in our second line, we have a variable a that's also going to hold a new memory object for our function state. And this time we're resuming our coroutine function, but we're passing the value 100. So when we go back, we run this line of code again. Because we've done everything on the right side of our assignment operator, the value 100 is now passed to our variable stop. And basically we're going to print out to console with the value inside stop, which is just going to be 100. So once we run into our yield function again, we stop, we go back. As you can see here, since this is the call that let us know that we're resuming our function, now we're going to pass that new yield function and pass that to variable a. From that variable a, we move on to the next line, and we basically resume, and we're passing a string value. So when we go back to our coroutine function, since we finished our yield, we take that string value, we pass it to our variable, and in this line, we go ahead and print that out to console. Now this line is very interesting. Basically, we're calling a yield function. However, notice how we're getting the node of our player class, and we're making sure we connect to the signal called health. Now our code pauses here. Basically, we will not run our code until we received a signal call. It's very important to note. So if we go back to our player function, we're basically going to wait for the emit signal. And in the emit signal, we're passing the value 200. So we wait, and we wait. We're only waiting for 2 seconds. However, in production code, you don't know when you're going to receive that signal call. But when you do, notice how we're going to pass that value 200 into our variable signal value. So in our first line of code, it's just basically saying a signal was received, but we take that signal value and we print that to console, and it's going to say value passed from signal to 100. So as you can see, you can do quite a lot of powerful things with coroutines in GDScript. That's all I have for you in this episode. Please go ahead and download the GitHub file and play around with coroutines. Coroutines are quite powerful when mixed with signals. You can do quite a lot of things. Basically, you have a lot of options on how to solve certain game programming problems. Thank you for subscribing to my channel, and thank you for clicking the like button. I look forward to seeing you in the next episode. Have an amazing day.